Please welcome Stefan of Bayer Technology Services.
The heart is a balloon, shoots up through the stony ground. There's no room, no space to...
Yeah, good morning. Welcome here in Düsseldorf. I'm going to give you some insight on what is happening in the pharmaceutical industry. So Alemeka is mostly focused on what biomaterial science does, plastics, rubbers. So we are looking here at what is happening in pharmaceutical. But before I start, a few words with regard to where I am from. So I'm working for Biotechnology Services. Is here a... No, here's no pointer, okay. So you see the Bayer Group. On the left-hand side, our business areas, Bayer Healthcare, Bayer Crop Science. Most of you will be familiar with the last one, Covestro, Biomaterial Science, which is going to be to the public market. And as of 1st of September, the new name is Covestro. On the right-hand side, we see the service areas, Bayer Business Services, our IT service provider, Currenta, and Biotechnology Services. That's where I'm working. So inside Biotechnology Services, we have three divisions: technology development, project management and engineering, and operations support and safety. So project management and engineering is executing the large investment projects for the Bayer groups. The two others, I'm very pleased that Valentine already gave you an insight what the other areas do, because technology development, they develop processes, and one of their key activities at the moment is the Factory F3, the modular factory of the future that Valentine presented. On the other hand, operations support and safety, to ensure safer and best-in-class reliability, efficiency, optimum productivity. We are dealing there, for example, with Industry 4.0. So Thorsten Pötter, whom Valentine mentioned in his presentation, he's sitting right next to my office. So that Valentine probably gave a better explanation what we are doing than I could do here. So enough as background information. So in my presentation, I will touch, first of all, vocabulary, serialization versus track and trace. What does it mean? Then give you an overview where these requirements exist already in the pharmaceutical market worldwide, the expected benefits, and what are the key factors for success. But before I start, who of you has already been in contact with serialization or track and trace? Could you raise your hands? Okay, that's not too much. So thank you for those who raised their hands. In all the others, I don't trust, because actually everybody of you has been in contact with serialization and track and trace, because probably everybody of you has a smartphone. And in consumer products, like smartphones, like TVs, serialization is a standard for years now. Yes. So, and to give you some figures, the sales of mobile phones in Western Europe is 174 million per year last year. LCD TVs are sold with 35 million per year in Western Europe. So, guess how many pharmaceutical packs are sold per year in the European Union? It's 30 times. It's 5.3 billion packs per year that are sold in the EU. So if you start to think about serialization, these products, so print individual numbers on these products, and trace these products through the supply chain. Yeah, we heard about did you have 1 million documents per day? Yeah, so 365 million documents per year. Here we are talking about, or transactions. Here we are talking about, if we only would have one transaction per pack, we are talking about 4.3 billion transactions per year. So serialization, how does it look in pharma? there is a de facto standard from GS1 that is applied in most of the countries that have already regulations. So we code the packs with a square data matrix code that includes a manufacturer product code, a random serial number, the expiry date, and the batch number. And you will see on the next slide why this serial number needs to be random. So it's square code, as I said, not the QR code that most of you will be familiar with from newspapers, journals, or something like that. Here we use the data matrix code because we need as well this GS1 structure to analyze the data in the code. So the scenario that is then built upon this data matrix code is the following. The manufacturer, on the left-hand side, he prints on each pharmaceutical pack the square code and uploads the code of the data into a central verification repository. Then the product finds its way through the supply chain to the pharmacy, and in the pharmacy, before handing over the product to the patient, the pharmacist scans the data matrix code. And the pharmacist's point of sale system then makes a request to this verification repository. And if a pack with this identity is found in the verification repository, then the pharmacist can sell the product. If the product is not found and the pack is marked as dispensed in the verification repository, if it's not found, then it's clear something happened. Maybe it's a counterfeit product or the manufacturer forgot to upload the data, which probably he will not make too often because otherwise he will be out of the market. Or it could be that the pack is already sold, and then you know at least that 2 packs with the same identity are in the market. And here it comes now, why do we need a random serial number? Because the standard way to counterfeit products today is that a counterfeiter buys a valid pack, and on this valid pack he finds the batch number and the expiry date, and he can then produce 10,000 packs that are identical batch number, identical expiry date, and he can sell it. So if we would have subsequent serial numbers and he would get access to a pack with a number 10,000, you would probably assume, okay, then the packs with the numbers 1 to 9,999 have been produced as well, and would himself produce counterfeit product with these numbers. That's where the randomization comes in. This scenario is real for each of you who lives in the European Union, because this is a requirement from the European Commission. Such system will be set up in each country of Europe until the beginning of 2019. So we are currently working to set up the IT landscape verification repositories, and we have started with one system, with a central European system, and are now going to the European countries to develop national or to introduce national verification repositories to make this happen within the next 3 years. So, and one of the key steps towards ending up with this scenario was a project, a pilot project that we have run in Sweden in 2009 and 2010. And on the next slide, you see a short video about what we have done there.
Stockholm, Sweden. Here in late 2009, FPA launched its pilot project to test its coding and identification solution. The project ran for 4 months in the greater Stockholm area and involved 25 retail pharmacies with a total of 180 dispensing points, 25 different products with a total of 110,000 packs, and 14 different manufacturers. The retail pharmacy chain Apoteket took part in the project. Pharmacists will be pivotal in working with the equipment and are therefore key figures in the likely success. Currently, pharmacists are heavily reliant on visual checks to make sure that medicines are not counterfeit. Under the FPR solution, pharmacists can identify each individual pack before it is dispensed to the patient.
The pharmacist scans the data matrix code, and a check is done with a database, which automatically tells us the status of the product, if it has been dispensed before, if it's been expired, and so on. And we get an immediate response.
Via scanning, the information contained in the data matrix is checked against the database at the manufacturer. And the pharmacist can immediately see the status of a medication.
This page shows us the FPA information, which is collected partly from the code and partly from the database. It holds the serial number, expiry date, and so on. And at the bottom it shows the status of the product in the database. So this one is verified and okay to sell.
Only if the product has a clear pedigree is it dispensed to the patient.
When you scan a product that is not verified, it shows no information about the product, and you also see that the product is missing in the database.
The FPR solution provides benefits for the patient and for the pharmacist.
The main benefits, I think, are increased security, where you can check with the database if it's an original pack. And also we have the expiry date in the code, which means we don't have to check it manually. And the system is also very easy to use and no difference to what we've done before.
So that was the example from Sweden. As I said, you will see it in a few years all over Europe. Then we come to track and trace. So far we talked about serialization and point of dispense, manufacturer, pharmacists. Track and trace, you know it, for example, from Amazon. If you buy something from Amazon, then you can track wherever your parcel is until it arrives at home. The advantage of these track and trace scenarios is that you have one logistics provider like DHL, and he can track the parcel in his system. The difference, if we do it here in the industry, we have the pharmaceutical company, we have a wholesaler, we have a distributor, we have the pharmacist. They all have different IT systems. And if we want to do track and trace here, they need to agree on a standard. They need to have at least an interface to a central verification repository. So in the middle you see it, track and trace means that as well the wholesaler scans each pack, the distributor scans each pack, and now imagine that we have a pallet of aspirin, buyer sells this to a wholesaler, and the wholesaler of course does not want to open the pallet, want to open the shipper box, take each individual aspirin pack out of the shipper box, scan each individual code. On the pallet there are 8,000, 9,000 packs. So what we need there is aggregation. And aggregation means that each object in the packaging hierarchy has its own serial number. So on the picture we see it on the left-hand side, each pack has a serial number, each bundle has a serial number, and we maintain the relationship which packs are in which bundle. Then each shipper box has a serial number, and we maintain the relationship which bundles are in the shipper, and in the end we have the pallet, and we maintain the information which shippers are on the pallet. We have the requirements for such track and trace scenarios in some countries. That's a large effort because of course it's clear you need to maintain this hierarchy accurate. So when we draw a sample, for example, in a warehouse, today somebody opens the shipper box, takes 3 boxes out, makes a note on the box that the shipper is no longer complete, done. In future, he has to go there with a scanner, take the pack out, scan the pack to tell the system the information which pack has been taken out as a quality sample. The same for the wholesalers who sometimes sell individual boxes, sometimes sell entire shipper boxes. So large effort. That's why we as an industry mandated for this point of dispense verification that you have seen in the video. But unfortunately, we have some countries that want to see the full aggregation and the track and trace. And why is that? So here you see a landscape of the applicable regulations. The first was Turkey, who required serialization in 2010, and 2 years later aggregation, so they have their system up and running. Then we have the European Union, I already mentioned it, beginning of 2019. Personally, I'm the country project manager for biohealthcare for Brazil, where we have a pilot phase end of this year and an expected go live end of 2016. And to give you an idea, Brazil does track and trace, and RX is prescription drugs. So Brazil has it for both prescription drugs and OTCs, where, for example, in the EU, it's only for the prescription drugs. Why is that? The EU has a clear target to fight counterfeit products, and OTC products are not that much at risk to be counterfeit. Therefore, the EU has decided to restrict it to prescription drugs. Brazil, they say it's as well, their target is patient safety, but what we hear is that the real reason is tax evasion. So in the states, in the states of Brazil, there are different tax rates, and if you are cleverly routing your product through the states in Brazil, you can optimize your taxes. And what companies today do is, of course, they don't transport the product through this large country, but they do the finance streams through the different states and optimize their taxes. And of course, that's not allowed, so the financial stream should follow the material flow, and therefore the Brazilian government wants this track and trace to see, was this product really in Sao Paulo, in Rio de Janeiro, in wherever in the country. That's why they require track and trace. So you see forthcoming regulation as well in the United States, serialization in the end of 2017, and track and trace then 6 years later. We have China starting next year with all our products. So it's real, the situation, and we expect a lot of countries to follow. But it's not only pharma. Oh, okay, first benefits. So benefits of serialization. We talked about patient safety. I talked about tax evasion, reimbursement fraud. That was the reason in Turkey. They had 3 billion euros reimbursement fraud per year before introducing the system, because up to that time, reimbursement in Turkey went that way, that the pharmacist had to take off a flap of the pharmaceutical pack, fix it on a sheet of paper and send it to the authorities to get reimbursed. And in times of good copy machines, of course, you can copy these flaps, and that's what people did. So they copied flaps, gave them to the authorities to reimbursement, and this summed up estimated 3.5 million euros. That's why Turkey introduced the system. You can use, if we step out of the pharmaceutical industry, you can use randomization for customer loyalty programs. That's something that in the agrochemical industry is sometimes done. So Syngenta is working on that, Bayer is working, I know BASF has a program. And serialization is the first step into track and trace. So track and trace does not work without serialization. Therefore, we always say those who want to implement track and trace first think about introducing serialization. Then track and trace, and have directly marked benefits only if you get the access to the transactional data, because in pharma, for example, we have the problem. We have this diverse supply chain with the distributors, with the wholesalers, with the pharmacists, and the track and trace data is somewhere, but we as a manufacturer don't get access to it. Yeah? And then we hear the consultants who tell us about supply chain visibility and inventory optimization. Yeah, great, if we would get the data, but the wholesalers and pharmacists don't want to give us the data. Yeah? So, but if we get it, then of course we have these benefits in supply chain, and as well the distribution channels can be controlled in times, for example, where you are short in products and route certain products to certain countries, then you want to see whether the product really arrives there or whether it's rerouted by one of your partners to a different country. So that was mostly pharma. There is as well an initiative in the agrochemical industry. Here, slide that Detlef Dönert from BASF has presented last year. So they want to introduce track and trace to get more transparency, to prepare for upcoming legislation. You see the other arguments down the list. Upcoming legislation, that is extremely important because what we as an industry want to avoid, and I assume that everybody of you would like to avoid, that the authorities tell us what to do. So and in the pharmaceutical industry, for example, we identified already in 2002 that the legislator would do something, and we started to develop a concept, this point of dispense verification concept, to suggest it to the authorities and to avoid that the authorities just rely on some consultants who want to make money, but money that we have to pay later. So, if you want to enter into track and serialization, track and trace. So typically, or technicians often start at the bottom and say, okay, it's difficult. Pharmaceutical packaging lines, they operate at 320, 350 packs per minute. So how can I apply these data matrix code that quick? How do I coordinate my entire operations? But if you want to do something, of course, you have to start at the top. So if serialization is not a means by itself. So what do we want to do? You want to detect counterfeits, you want to control the distribution channels, all the arguments, benefits that you have seen on the previous slides. That's, from my opinion, the first step into serialization, track and trace. Then you need a system, and the question is, who should be the governor of that system? Should it be authorities? Should it be the industry? If it's the industry, you need collaboration like you have it, for example, on a Lemica platform. Then you have the data capture topic. You need to collect the data. You need to collect the data in the external supply chain. You need as well to collect the data in-house from the time you are producing and printing the codes until it leaves the factory. So, finally, what can I recommend? So, there are benefits of both serialization and track and trace, and there is I think, a hype in the industry, digitalization. Everybody talking, we had smart manufacturing, industry 4.0, so are we prepared for digitalization? So, if you have an idea of a business case, for serialization, then I think it's now the time to introduce it to your management, because there's a high likelihood that they listen and want to engage in such things. Then don't be over optimistic with regard to technology. So I'm personally surprised to see how less mature this printing technology, for example, is. So as a technician, normally I would have said that's easy, that's straightforward. So even to implement serialization on our packaging lines, that's really complicated. And then there come the people who say, why do you use a data matrix code? RFID would be much better. Yeah, but there are so many, apart from that the costs are higher, there are so many technical hurdles that you, of course, can have a vision where you want to end up with, but try to do a first step with a less complex set up. Then do not underestimate the time for alignment with partners. So on the bottom you see the timeline of what FPR, that's the European Federation of Pharmaceutical Industries, who ran this project in Sweden. So they started, the European Commission started to discuss it in 2002. FPR said in 2005 we need to do something. In 2008 there was a first proposal by the European Commission, and the president of FPR at that time said we want to do a pilot. That was where I started in this initiative and where we prepared the Sweden pilot. Then in 2011 it went into the Commission, and the problem after the Sweden pilot was, for us, it was quite successful, but then we were successful, and then we stood there and said, okay, what do we do now? We as FPR, we are successful, but what's the next step? And then we realized, okay, we need the wholesalers. If we wanted to make a success, we need the wholesalers, we need the pharmacists, we need the parallel traders. And that was funny at that time, because up to that day, on the FPR webpage, you could see that parallel trade should be banned in Europe. And then all of a sudden we went to them and we said, hey, do you want to collaborate with us? So really difficult. So, and what I said, therefore, what I said, don't underestimate the time to implement such things. That's not an easy win in 1 or 2 years. It takes several years. Thank you very much.